So this is what we have defined. So S is an n element universal set and P1, P2, etc. PQ are properties on S. ഇനി നമ്മളൊരു property എടുത്തു കഴിഞ്ഞാൽ property may be possessed by none or some or all of the elements. ഇനി അതുപോലെ ഒരു element എടുത്തു കഴിഞ്ഞാൽ an element may possess none of the properties, all of the properties or some of the properties. So that depends on how you are defining your properties. Properties നമ്മൾ define ചെയ്യുന്നതാണ്. അത് നമുക്ക് ഇഷ്ടമുള്ള രീതിയിൽ define ചെയ്യാം. Okay. So that is how we have defined the properties. Now for integer m with 0 less than or equal to m less than or equal to q. So let me define e of m to be the number of elements that possess exactly m properties. So total we have q properties and m is any number which is lying in the interval 0 less than or equal to m less than or equal to q. And let me define e of m to be the number of elements that has exactly m properties. അപ്പോൾ നമ്മൾ എസ്സിലെ എലമെന്റ്സ് നോക്കുക. എസ്സിലെ എലമെന്റ്സിൽ എക്സാക്ട്ലി m പ്രോപ്പർട്ടീസ് ഉള്ള എലമെന്റ്സിന്റെ എണ്ണമാണ് e of m എന്ന് പറയുന്നത്. ഓക്കെ, സോ let e of m denote the number of elements of S that possess exactly m properties and for 1 less than or equal to m less than or equal to q. So let me define omega of pi1, pi2, etc. pim denote the number of elements of S that possesses the properties P, I1, Pi2, etc. Pim. Okay. അപ്പോൾ E of M എന്ന് പറയുന്ന that is the number of elements of S that has exactly M properties, and omega of Pi1, Pi2, Pim എന്ന് പറഞ്ഞാൽ that is the number of elements that possess the properties Pi1, Pi2, etc. Pim. Okay, and let me define omega of m to be summation over omega of pi1, pi2, etc. Pim. So where summation is taken on over all m combinations I1, I2, etc. Im of 1, 2, 3, etc. Q. Okay. അപ്പോൾ നമ്മൾ ഡിഫൈൻ ചെയ്ത മൂന്ന് കാര്യങ്ങളാണ്. E of m എന്ന് പറയുന്നത് that is the number of elements of S that possess exactly m properties. Exactly m properties possess ചെയ്യുന്ന elementsന്റെ എണ്ണമാണ് E of m എന്ന് പറയുന്നത്. And omega of pi1, pi2, etc. pim denotes the number of elements that possess the properties pi1, pi2, pim. അപ്പോൾ ഈ m properties pi1 ഉം pi2 ഉം pim ഉം properties possess ചെയ്യുന്ന elementsന്റെ എണ്ണമാണ് omega of pi1, pi2, etc. pim. അതുപോലെ ഇനി omega of 3 define ചെയ്താൽ omega of by 3 I mean that is the elements possessing 3 properties. Okay, അപ്പോൾ എനിക്ക് x1 എന്ന് പറയുന്ന എലമെന്റ് p1, p2, P3 എന്ന് പറഞ്ഞ പ്രോപ്പർട്ടീസ് സാറ്റിസ്ഫൈ ചെയ്യാം. അതുപോലെ X2 can satisfy the property P1, P2, P4. So here you have all the three combinations. അപ്പോൾ നമ്മുടെ Q പ്രോപ്പർട്ടീസിൽ നമുക്ക് ഏതൊരു 3 കോമ്പിനേഷൻ എടുക്കാം. I can take 1 2 3 അല്ലെങ്കിൽ 1 2 4 അല്ലെങ്കിൽ 2 3 4. അപ്പം അറ്റ് എ ടൈം 3 പ്രോപ്പർട്ടി സാറ്റിസ്ഫൈ ചെയ്യുന്ന combinations എടുക്കുക. So that count will give omega of m. അപ്പോൾ omega of pi1, pi2, pim എന്ന് പറയുന്ന that possess the properties pi1, pi2, pim. The omega of m is the summation over all m combinations. So that is omega of m. And we also define, so we also define omega of 0 to be cardinality of S. So here omega of 0 is cardinality of S. So here we have taken an n element set. So omega of 0 is defined to be n. So with this we can now define the generalized principle of inclusion and exclusion. So we will use E of m and omega of m to state the generalized principle of inclusion and exclusion. So this is the context in which the generalized principle of inclusion and exclusion is explained. So we have a universal set, some properties defined on the set. Then we have defined E of m to be the number of elements possessing m properties, and omega of m is summation over omega of any m combinations. Okay, so let S be an n element set and let P1, P2, etc. PQ be a set of Q properties for elements of S. Then for each m equal to 0, 1 to etc. Q. So the generalized principle of inclusion exclusion states that E of m is equal to omega of m minus m plus 1 cm into omega of m plus 1 plus m plus 2 cm omega of m plus 2 minus etc. plus the last term is minus 1 raised to q minus m qcm omega of q, or that is equal to summation k equal to m to q minus 1 whole raised to k minus m kcm omega of k. So this is the generalized principle of inclusion and exclusion. So in the next class we will verify this principle, and we will see the proof for the generalized principle of inclusion and exclusion.